Here we go. Quiz number 1. Quiz number 2, sorry. Good old Anne. Suppose this mass begins from rest. I would probably underline the word from rest. Wants me to find time. Okay, well. To find time, I know D equals 4.8. You know what? If I could find the acceleration, then I could use okay. So even though this says find time, I think I'm going to spend most of my time finding the acceleration. Probably a job for a good free body diagram. Let's see. mg down. Does it say it's sliding up the hill or down the hill? That's important. Normal force. What if I was sliding up the hill? Which way would I draw friction? Down. I'd have two winners. Okay, this isn't good. I have to go components. mg perpendicular and mg parallel, where that's a lovely right angle. Okay, who's winning? If it's sliding down the hill, my equation is winner minus loser equals ma. It's going to be equals ma. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Perpendicular. So it's going to be mg sine theta minus mu mg. Which one was perpendicular? Of course it was. Hey, Mickey, is there an m in everything? So what happens to that there m there? Cool. So I get the acceleration is going to be g sine, what did I say theta was? 53? Minus, what's mu? I don't know, what's mu with you? 0.44, that's a pretty sticky slope. 9.8, or g cos 53. A little loud upstairs, but whatever. 9.8 sine 53 minus 0.44 times 9.8 cos 53. Do you get an acceleration of 5.2316 blah, blah, blah? Okay. Is that my final answer? I'll carry some extra sig figs then. I'll go 5.2316. And now I'll plug that in way up here. The square root of 2 times 4.8 all over 5.231. Are we slowing down or speeding up? Rob, so do I make the acceleration negative or positive? What if I was slowing down? What would I have to add? Here's where I'd have to add a negative, but I'm good. So it's going to be 2 times 4.8 divided by answer button. Square root, Mr. Dueck. 1.35, is that right? Yeah. So if you got that, or 1.34 or 1.36, 4 out of 4, okay? Otherwise, in terms of part marks, I would probably do something like this. Let's see here. 1, 2, 3, 4, 5, 6, 7. You know what I think I would do, actually, is I would give half mark for that, 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 half mark for that. 1, 2, 3, 4, 5, 6. Half mark for the acceleration, and a half mark for the time, something like that. I'd give you 2 out of 4 for finding A, because that's the hardest part, and then 2 more marks for finding time. I don't know, is it out of 40? Is it out of 4? I don't know, what do you think it's out of? So, if you want to, I can bring this up again, but basically I'm probably giving about a half mark for each line that's right. Next page. Number 2, an Atwood machine. A little tricky Atwood machine because they didn't give me a mass. I would draw the acceleration arrows. Oh, I did in the picture for you. Okay. Well, I'm going to start out the same way. M1G tension. M2G tension. It says find the tension. They gave me the acceleration, so I think and they gave me mass 1. I'm going to write tension minus M1G equals M1A. Tension is going to be M1A plus M1G. Tension is going to be 5.9 times 3.6 plus 5.9 times 9.8. Do that one in your head, Mr. Dueck. Well, let's see if I can. I can factor out a 5.9. It's going to be 9.8 plus 3.6 is going to be 12.8. It's going to be 13.4. 5.9 times 13.4. Well, 6 times 13.4. Oh, yuck. It's going to be 70. It's going to be in the 80s somewhere, I think. I don't know. Let me see. It's a Friday. Oh, just below 80. 79.06, is that right? Yeah. Is this a final answer? Then I'll go 3 sig figs. Two marks. You know what? I would probably go half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. But again, Rafi, as always, if you get the right answer, I generally give you full marks unless it's clearly obvious that you cheated. Really? I had one kid a couple of years ago that would just write an answer down on the written sections of all of his tests, and the kid really wasn't a strong physics student. He tried to claim they were doing it all in their head. Yeah, right. Please. Find M2. Well, let's draw let's write an equation mark for M2. If I look at M2, who's winning? I think there, winner minus loser equals M2A. Naomi, how many M2s do I have in this equation? How many would I prefer? Let's get them all to the same side, and anything without an M2 to the other side. So the first thing I would do is I would rewrite this as M2G minus M2A equals tension. Naomi, how many M2s do I have? How many would I prefer? It'd be wonderful if there was like a little grade 9 mathematical operation that I could reach into my back pocket for and pull out and somehow turn this into just one. And there is. What? Turns out I can factor out a GCF. And again, I love the fact that in Physics 12, it's really Math 9 that comes to the forefront here. It's, by the way, it's also like, I mean, how many times this year have we used grade 8 Pythagoras and cross-multiplying for Pete's sakes, right? For Pete's sakes? I don't know, I can't talk. It's a Freudian slip. You say one thing, but you mean another. I was helping someone with their ACT testing earlier today, just doing some practice exams, and there was one really nasty question. It ended up being Math 8 cross-multiplying when all was said and done, which was very cool. Okay, mass 2 is going to be tension. Now I'll use the full value, 79.06 over 9.8 minus, what did I say the acceleration was? 3.6? You get mass of 12.8 kilos? No? Yes? Yeah. Again, 2 out of 2 for that. Otherwise, I would probably go something like a half mark for that. I'd probably go a half mark for the factoring. Half mark if I saw the m by itself. And a half mark for the actual answer. You okay with a half mark, Mark? Yep. Okay. Next page. Student of mass M places a bathroom scale on a skateboard. Hey, as soon as Dueck starts talking about a scale, he's really talking about normal force. What will the scale read? Well, initially, if everything is level, the scale is just going to read M. M. Now, okay. Why? Here's how I would answer this, and there are other ways. If you're not sure, after I finish with this quiz, bring it up, lawyer with me, and I'll tell you how many marks I would give you. But I think, you know what my approach would be? What's been my approach on most of these force questions? I would dollop in a free body diagram. And I would say, okay, if I draw this, I don't care about the person. What are the forces? I have this. I have that. Friction, not with a skateboard. Then I would break it up into so how would I give you 2 marks? If you drew that, or if you said that's good. And then if you were clever enough to say that's good. Now, cosine. You guys have done the cosine button fairly often on your calculator. Is cosine ever bigger than 1, or has it always been a decimal less than 1? It's always been a decimal. So if normally, no pun intended, the normal force is mg, but you're multiplying it by a decimal, is your new answer going to be bigger, smaller, or the same size as mg? Got to be smaller if you're multiplying by a decimal less than 1, right? If you're multiplying it by 0.8 or 0.5 or whatever the cosine is. Now, I said something like that. Basically, what I'd like you to do is look at your answer. If in your answer you referenced that the normal force is the same as mg perpendicular, and you referenced therefore it must be smaller, you could also have used, remember we gave the argument of if theta was 0 to theta was full, and you said, well, you know what, if theta is 90 degrees, then the normal force is 0, so as you're getting bigger, normal force is getting smaller. There's all sorts of options. If you think you gave an intelligent answer, give yourself 2 marks. If you're not sure, show it to me after I finish marking the quiz, and I'll give you a quick eyeball and say what I would give it. Okay? Let's go on to question 4. Find the acceleration. Now, I have to first of all figure out which way m1 is moving, is accelerating, up or down. This one is a little easier because, Sabrina, how big is m1? How big is m1? I caught you zoning out, sorry. How big is m1? Don't write this down. How big is m2? If m2 was hanging straight down, best case scenario, it would still be losing because m1 is 11. Is it hanging straight down? It's at an angle, which means it's applying even less of a force with no friction. So, you know what? I'm going to guess this is the winner because it is. Again, if I guessed wrong, I'd get a negative answer, and I'd quickly flip everything. I've showed you how to do that. So, free body diagram, I have M1G, tension. I have M2G, normal force number 2. Friction? No, it says no friction for this part. I will break this up into M2G perpendicular and M2G parallel, where this angle and this angle are the same ones. Who's winning? I think my equation is going to be winner, and then there's going to be a minus tension and a plus tension, minus M2G parallel. Have I looked at more than one mass on the left-hand side for forces? Well, I better have more than one mass on the right-hand side. Did I leave you guys room here? No, I didn't. Yeah, okay. So I'm trying to fit it in on the side. Love it when I lose tension. Hey, Mac, what are we trying to find? How would I get the A by itself? Can I do it on this line? Sure. How would I get the A by itself? There's there. How am I going to move that over? Divide. Can I do that? You okay? I'm going to do that in one step. So on my next line, I'm going to go, okay, A equals M1G minus M2G parallel M1G minus M2G sine. Let's plug in numbers. A equals 11 times 9.8 minus, what was it, 7.8? Times 9.8 times the sine of 36 degrees. All over 11 plus 7.8. By the way, note diagram is not to scale. Definitely not, because 36 degrees is only about this steep, not this steep. But I wanted to give you an exaggerated diagram just to show you what the components look like, because they look a little different than we're used to, right? Bracket 11 times 9.8 minus 7.8 times 9.8 times the sine of 36. Oh, too many brackets. Divided by bracket 11 plus 7.8. You get an acceleration of 3.344132, 3.34? Yep. Again, 2 marks if you got that. Otherwise, I would probably go half mark for the big equation, half mark for getting the A by itself, half mark for doing the trig, half mark for the answer. Find tension. I can find tension using mass 1 or mass 2. Which one is going to be less ugly? Mass 1. Mass 1. Even though it's a loser, it's going to be way less ugly because I'm not going to have all the components and junk. So finding tension, I'm going to choose to go winner minus loser equals M1A, which if I get the tension by itself is going to be M1G minus M1A equals tension. Tension is going to be M1, 11, 9.8, minus 11, 3.34. 11 times 9.8 minus 11 times, answer button. Do you get, 71 even? 71.0 newtons? No? Yes? doesn't look like a 1. It looks like a weird bracket. Okay, mini curveball. What would the minimum coefficient of friction need to be to hold the entire system stationary? Okay. Which way is mass 2 moving right now? Up. So to hold it stationary, which way do I need to point friction? Right? So my new equation is going to be winner minus loser plus winner minus M2G parallel, also minus friction. Ah, that's why this falls apart a little nicer. Equals nothing. Stationary acceleration is 0. Yay. Okay. This is going to be M1G. Change colors, Mr. Dueck. M1G minus M2G sine theta minus Grayson friction is what times what? I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. Which one, kiddo? I got the mu part, but I want the normal force. Did you say M2G perpendicular? If you didn't, nod your head anyways. Yep. Is that what you said? Cool. I got a mu, and they're asking me what's mu. I don't know, what's mu with you? No, they're asking me to find what's mu. Oh, and G perpendicular, oh, of course it is, right? So I'm going to get M1G minus M2G sine theta minus mu M2G cos theta equals 0. Mickey, is there an M in everything? Not the same M. There's an M1 in the first and M2 in the next. Is there a G in everything? Is there a G in the 0 too? Actually, you can divide everything by G, including a 0, because if you divide 0 by anything, the answer is 0, except for dividing 0 by a 0. That's a whole discussion. Anyways, you'll find out in a second. The G's are going to cancel, and if you didn't see it, I'm going to do a bit more. What are we trying to get by itself? Mu. I'm going to actually plus this to this side so the mu is no longer negative. And I'll get that looks a little prettier to me. What are we trying to get by itself? How would I get the mu by itself? Mark? Okay. And now you can see there is a G in everything, right? So I can even do that. I'm just going to divide by M2 cos theta. So what's mu? I don't know what's mu with you. Mu is going to be M1 minus M2 sine, all divided by M2 cos. It's going to be M1, which was 11, minus 7.8 sine, what was the angle? 30-something. 36? All divided by 7.8 cos 36. Mickey, can I cancel out those 7.8s? Why not? You're right. And by the way, I'm picking on, Mickey made the mistake at the beginning of the year, but I'm doing this because this is one that kids do all year long and it drives me crazy. So I'll pick on you, but I'm really enforcing it with the rest of the class, much like my hammering the mu times the normal force. Also because I get to damage your self-esteem a little bit. That's just icing though. That's just a bonus. You're right. It's got to be, there'd have to be a 7.8 in that 11 somewhere as well. 11 minus 7.8 sine 36 divided by 7.8 cos 36. Do you get 1.01? What's that mean? Now, usually we don't have a mu bigger than 1. What it means is you'd actually need to have some kind of glue because it has to have a coefficient of friction bigger than 1 means, oh, it can support its own weight and some more, like glue. It also means, Nate, that I made up these numbers and didn't bother crunching them ahead of time. 1.02. Units. Nothing. Mr. Dueck, how would you give up part marks for that? Whew, boy. Probably a half mark if I saw that equation. Probably a half mark if I saw this equation. Probably a half mark if you got the mu by itself, and a half mark for the answer. Let's go skiing. Number 5, also asking me to find mu. Okay. Any suggestions on how I might start this? Find the acceleration. How would I do that? Well, it turns out actually I have enough information to find the acceleration without going forces. I think what I'm going to do, though, Jordan, I'm going to get mu by, write an equation with mu using forces, get mu by itself, and then I'll say, okay, let's go find A, because I think that's what I'm going to need. I think that's why they gave me the time and the from rest and the 20 meters per second. I think I can pull this off. So I would first of all say to myself, I got mg down, normal force, friction up the ramp, mg perpendicular, Mr. Dueck, not parallel, perpendicular, mg parallel, where this angle and this angle are the same. Who's winning? Losing equals ma. I think what I'm going to try and do is I'll solve for acceleration over on the right, but I think I'm going to need more room to get the to get the mu by itself. This is going to be mg sine minus mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. In fact, I think it's going to be mg sine minus mu mg cos. Yay. By the way, again, Mark, the fact that the mass cancels, this explains why a little child can ski with a grown-up, because they have different masses. And the grown-up and the child aren't constantly having to adjust their speed. Now, there is also skiing skill, because you can control your speed with your skill level, but that's a different issue. If you just literally get into a tuck and stay there, for the most part, the kid and the adult will be side by side. Air resistance, as you get up to a bigger speed, will start to play a role, because an adult's bigger than a kid, fair enough, but in our magic physics world, ideally, this is how it works. What are we trying to find? Mu. You know what? Shaq, I'm going to plus the mu to this side and minus the a to that side at the same time. I'm going to get this. Not in red, Mr. Dueck. I'm going to get g sine, take away a equals mu g cos. Nate, my friend, how could I get the mu by itself? Divide what over? G sine? This? Is the mu right here? So I think I want to move this. Of course you did. Of course you made a mistake. You didn't spot the signs. That was a near miss. It just gets worse and worse and worse. I know. Now, you ready, Nate? Look up. Do I know G? Well, yeah, I have since grade 10, 9.8. Did they tell me the angle? What don't I know here? A. So I got to pause. Well, what did they tell me how much time elapsed? 8 seconds? Did they tell me VI? 0? That doesn't look like much of a 0. Did they tell me VF? Sorry, what's VF? 20? Do I have an equation that has T, VI, VF, and A in it? What? There you go. Equals 20 minus 0 over 8. Heck, I think I can do this in my head. 20 over 8 is 10 over 4 is 5 over 2. 2.5? Now let's go plug that in over here. It's going to be 9.8 sine 16 minus, was it 16 degrees? Yeah, okay. All over. Yep. Quick like a bunny. I have no idea what the answer is. By the way, are we on a ski slope? Are you expecting a really, really big coefficient of friction? Or it's snow? And hopefully if I tried to make up reasonable numbers, I'm hoping I don't get a coefficient of friction bigger than 1. But let's find out how good I was in my head. Bracket 9.8 sine 16 minus 2.5 divided by bracket 9.8 cos 16. Oh, okay, that's snowy. That's slippery. 0.021? 0.0214 if you want to go to 3 sig figs. Is that okay? All right, part marks. Well, I'd probably give you 1 mark for finding the acceleration. I'd probably give you 1 mark if I saw that. 1 mark if you got the mu by itself, and 1 mark for the answer. I didn't break it down to half marks this time. Can you give yourself a nice, lovely, clear score out of, count 'em, 22, please? Any lawyering with me about the using principles of physics right to explain? Now is the time. Lesson 8. I'll take questions on that in a second, but I want to get lesson 8 done. Because I think, let me double check here. Yeah, I got some homework, but I'm going to be not giving much of it. Ready? Also, I'm gambling that some of my answers for some of lesson 8 might help you with lesson 7. So lesson 8 is called various 2D force problems. And the first one is the lawnmower problem. I like this question. I like this question. I like this question. Maybe. What is the lawnmower problem? I'm assuming all of you have seen and some of you have pushed a lawnmower. It's where you're applying a downwards or an upwards force at an angle to the ground. So if you're pushing with a lawnmower, you push down the handle at an angle. Or you can imagine instead of this being a handle of a lawnmower, what if it was a rope and you were trying to drag it? You'd fling it over your shoulder so the rope was up at an angle even though you're dragging it horizontally. Regardless, you're mucking around with the normal force. You're either adding an extra downwards force or you're lifting up partly as you pull sideways and you're lowering the normal force. And again, this is why friction is going to be mu times the normal force. But this time when I say I don't know the normal force, look, we're probably going to have to do some real thinking. You ready? So definition, a problem where we have vertical force components other than the normal force at mg. Usually someone pushing down at an angle or pulling up at an angle. So the key idea in a problem like this, the normal force is not equal to mg, or on a ramp, the normal force is not equal to mg, of course it is. Not equal to perpendicular component. Example 1, I like example 1, I like example 1, I like example 1. Find the normal force, friction, and acceleration. Okay. Any suggestions on how we're going to start? Label diagram. What are the forces acting on this? Get the obvious one. Get the obvious one. Do that first. Go systematically, Joseph, my friend. Okay, I'm going to come back to the normal force for a reason. What else? I'm going to save the normal force this time for last. Sorry? Friction. Which way do you think this is going to slide? To the right? So which way should I point friction? Let's do that. And then, Joseph, what was the first force that you mentioned? No, the very first one. Okay. The applied is that handle. See the handle, the 200 newtons? What don't we like about that handle? So, if it's on an angle, how have we dealt with that? Okay, so here's what I'm going to do. I'm going to break it up into, and since it's vertical, I'll call it Fy. And since it's horizontal, I'll call it Fx. Now, what was the one that I said we were going to come back to? See, don't write this down. See if you can tell me why this would be wrong. Drawing the normal force the same size as mg, why would that be wrong? This. Yeah, you know what? The normal force now is canceling out mg and this. So if I was eyeballing it, the line that I'm going to draw is this plus this. Pick up your pencils. I'm going to draw an exaggerated, a much bigger normal force. And Grayson, friction is what times what? So you know what? If the normal force is so much bigger, Grayson, what can you tell me about the force of friction? Bigger, smaller, or stays the same? Bigger. This is why, and I've mentioned this before, but this is why when you're trying to slide something, you're stupid if you push down and try to move it. I've increased friction so much that I can't move this thing. This is why if you're trying to slide something really, 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 really heavy, what do? You lift up. What does that do? Reduces friction. How? By reducing which force? Normal force. Okay. So, first thing it says is find the normal force. Let's call that part A. Let's call that part B. Let's call that part C. So find the normal force. Let's do that right here. A. Can you give me an equation for the normal force? In other words, what's the normal force canceling out? The normal force is canceling out gravity, normally, and the vertical component. What if instead of pushing down the handle, what if we were tugging up the handle? Then the normal force would be smaller. There'd be a minus sign over it. But anyways, we're good. Okay. Any thoughts now? I think maybe we better do some trig to figure out what Fy is. So here's my angle. Fy, opposite, adjacent, or hypotenuse. You know what would really be convenient? What would really be convenient would be if Fy was sine. That would be really, really, that would almost be too much to hope for. Let's see. Opposite. That 200 newtons that the diagram gave me. Adjacent or hypotenuse? Hypotenuse? So if I hear you correctly, you're saying the sine of the angle, I'll put a theta there. It's a 20 in this question, but I'll generalize, is equal to Fy over 200? How would I get the Fy by itself? I have no. Oh. Eric, what was that? FYI, FY is 200 sine? Yes, it is. So the normal force is going to be mg plus 200 sine. Is it 20 degrees? 20 degrees. What was m? Please tell me. 50 times 9.8 plus 200 times the sine of 20. And I get 558.404. Well, since this is a final answer, I'll go to 3 sig figs, 558. Units. Newtons. Okay. Cool. What's B want me to find? Hey, Grayson, can you give me an equation for friction? Friction is what times what? Lovely. I don't know the normal. Wait a minute. I do know the normal force because I just calculated it. But if we hadn't done that, I would do my usual, I don't know the normal force, and I would say, look, 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 look. But then I would say, ooh, I know several forces that can help me figure out the normal force. But it's not like I can just see it instantly necessarily. But this time, I can go, what's mu? I don't know what's mu with you. 0.1 from the diagram times 558. I think I can do this in my head. I think it's going to be 55.8. 55.84, but 55.8 newtons. Jack, what's C want me to find? Okay. What direction is this thing going to be accelerating? To the right. Who's winning? FX. The most common mistake I see kids say, 200's winning. Is the 200 slanty at an angle? Then we're not going to use it because that's not in the direction of the acceleration. And this goes back to my vector rant last unit too. We want to make sure stuff is in the same direction. So if we're accelerating horizontally to the right, who's winning? Horizontally to the right, FX. Who's losing? How many masses? Just one? MA. Friction, I just calculated on the previous line. If I hadn't done that, I would walk through steps A and B and get friction. FX. Let's get tricky. It'd be really convenient if, since sine is y, sure would be nice if fx was of cosinus. Let's find out. Adjacent hypotenuse. Oh, look at that. Cos 20 equals fx over 200. How can I get the fx by itself? Times by 200. Okay. Oh, and Shaq, what did you say we're trying to find in part C? How would I get the a by itself? Divide by m. So a is going to be fx, which is 200 cos 20 minus friction, which if I didn't know, I'd have to go through the A steps A and B, but I got it sitting there, 55.84, all divided by 50. $200 cos 20 minus 55.84 divided by 50. Do y'all get 2.64? I'm almost certainly going to give you a lawnmower question as a written question on your test. It's either going to be pushing down or pulling up. Also, this makes a good, hey, draw the free body diagram question. And in particular, I pay attention to the size of the normal force, whether it's bigger, smaller, or the same size as mg. Okay. So far, so good. Example 2. We could handle, especially because of this here, we're just going to set it up. What are the forces acting on the block? Get the obvious one. So I have gravity down. I'll draw it nice and big for a reason. Don't draw the normal force yet. It's going to be weird. What else? No friction, because the question doesn't mention any. Or maybe there is friction. Which way does this block want to slide? I guess there has to be friction, because otherwise if it was ice, it'd be sliding. So which way does this block want to slide? So which way is friction pointing? What else? The applied force. I'm going to leave the applied force where it is, but now I'm going to go components, and I'm going to say, okay, here's mg perpendicular, here's mg parallel. How big is the normal force? Now, normally, no pun intended, I've drawn the normal force like that. Why would that be wrong this time? How many forces are pushing into the ramp? 2. The normal force here is going to cancel out this and the applied. The normal force would be big. In fact, you know what? Let's exaggerate it, Mr. Dueck. Bigger, which would make friction bigger, which is probably why this is able to remain at rest. I'm not going to bother solving this, but there's our setup. Yep. Give me 30 seconds. Static equilibrium, cool, but I'm going to skip it because of our late start this year. I won't put it on a test. Accelerometer problem, cool, but I'm going to skip it because of our late start. So what's your homework? Try this lawnmower question. Try this lawnmower question. Please notice that we're pulled. You probably want to dulp. You can draw example 1 or exercise 1 up here, exercise 2 down there if you need to. 3 is a little blah. 5 is a little blah. Meh. 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 Ah. Number 11. $12. I'll go 13. You can skip 14. I figure if you do 3 of those, you'll get the hang of it. Okay. Okay.